Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub, the place where you get a lot of O and A level math content. So now in this particular video, our focus is on this mid-year exam. It's about P3 and these are the topics that are included in this particular exam. So out of the 9 topics, 7 out of 9 topics were included in this exam. Which 2 topics were excluded? Complex numbers and vectors. Now let's look at the first question. The first question is about modulus sketch. It's about modulus inequality. Let's focus on the sketch first. We are supposed to sketch this graph. Now the first thing that I did was I sketched this graph. It has a positive slope, a negative y-intercept. That's the positive slope. That's the negative y-intercept, which is -3. I also found the x-intercept and what is about the modulus, what is the absolute value function. That is positive remains positive, 0 remains 0, but negative becomes positive. So this portion of the graph is reflected up over here and that's the V-shaped graph that we have obtained. Now let's look at the second part. That is about solving this inequality which is written over here. So we are supposed to solve this inequality. Now I prefer to use the algebraic method. I'm not very comfortable. I don't feel like doing the thing related to graph. The reason being you have to find the point of intersection and do things like that. So it's much better, much easier from the perspective of the student to apply this particular method. So now this is like x modulus less than a, x lies between -a and +a. So this is x, this is a, this is x, this is +a, this is -a. Open this up separately and we get this thing. Open this up separately, we get this thing. Now when two inequalities are moving in the same direction, what we do is known as a true-false test. So what do? We choose a number, a convenient number between -5 and 1/5 that represents this particular portion of the number line. So the best number that I can think of is 0. The second number should be representing this part of the line, this part of the number line. So I chose 1. So now plug in x is equals to 0 in the original inequality, plug in x is equals to 1 in the original inequality. What happens? We are getting 3 is less than 2. Is this true or false? Definitely it's false. And over here when I plug x is equals to 1, this inequality after plugging in is true. That means this portion of the graph is true, this portion of the graph is not. Therefore the final answer is this particular portion, x is greater than 1/5. Now look at the mark scheme, they have not really explained it. And this thing is never to be done. When there is modulus on one side, never square both sides. So let me write it down very perfectly. Modulus on left hand side only. So never square both sides. Either it's of the format x modulus less than a, which is the same thing as x lies between -a and +a, or x modulus is greater than a, which is the same thing as x is lesser than -a, x is greater than +a. So this is case 1. The way that I teach, I refer to this thing as case 1. This is case 2. And case 3 is modulus on both sides. When we have modulus on both sides, then it's the only option, square both sides. So that won't cause any trouble. But in case 1 and case 2, if we square both sides, we get extra solutions which we may not know whether it exists in reality or not. That brings us to question number 2. As you can see, this is about linear law. A graph of ln y against ln x is drawn. It passes through these 2 points. That's what it's written over here. This particular equation is given. So let me just highlight this particular equation right over here. That is this equation. That's how the variables are connected. Now we are supposed to find the value of n and find the value of c correct to 2 dp. It seems that the value of n will come out to be either a fraction or an integer or an exact decimal. Let's see. Now the very first part, this is about coordinate geometry. You find the gradient between these 2 lines. And the second thing, plug in the gradient, find the y-intercept. So these are the first 2 things that needs to be done. That's coordinate geometry. Second part, this is about linear law. This is about applying the rules of logs. So now we take ln of both sides because we see there is natural log written over here. If it was LG, we would have taken LG of both sides. Now, when we take ln of both sides, the multiplication rule applies. It changes into addition. This power rule applies. This power comes down and multiplies. Make ln y the subject. Ln x is on the x-axis, so the coefficient of ln x is the gradient. And the constant all alone is c. Step 3, join coordinate geometry with the linear law thing. So negative n over 2 is equals to m. The value of m is negative 0.4, negative cancel, n is 0.8. That is why they did not mention the accuracy. So every single word that the examiner writes makes sense. Half ln c equals to this c that is just found over here, and c is e raised to power of this thing, 14.41. That's the answer, correct to 2 dp. All good, all clear. Now question number 3, polynomials. The polynomial is denoted by px. It is given that px is divisible by 2x minus 1. This is known as factor theorem. That means if I equate it to 0, 2x minus 1 equals to 0, x is equals to half. If I plug in this value, I get a remainder of 0. And then px is divided by x plus 2. The remainder is 5. So x plus 2 is not a factor. That means if I plug in negative 2, I'll get 5. So I form two equations, take care of the fractions and everything. So that is why O-level maths basics is very, very necessary. It's about numbers, arithmetic. It's about algebra. These two are the heart and soul of A-level math. You solve these two simultaneously. You find the value of A, you find the value of B. Let's move on. Question number 4. X term, algebraic term multiplying with ln. This is integration by parts. What is the formula? Integral of u dv, that is uv minus integral v du. Apply the rule for LATE. This is the order for choosing u. Whatever you choose u, you differentiate. So choose u, let me highlight it. Choose u, differentiate. Choose dv, integrate. Follow the formula. Either you follow this formula or you follow my way of doing it, which I have learned it from my teacher. So this is uv minus integral v du. And when you do this, coincidentally, you are getting the same thing as above. So be very, very vigilant. So I just inserted this answer over here. I took a lot of common. Let me show you what I have taken common. I have taken 2/5 common. Actually, this 2/5 on the inside, let me write it. This x power 5 over 2 is common. So what is left? Ln x is left over here, and this 2/5 is left over here. 2/5 is left over here. Ln x is left over here. And over here, this 2/5 x power 5 over 2 is common. And what are the limits? The limits are 1 and 4. So first I have written it. This is where you insert the limits, the red one. This is where you insert the limit, the blue one. So red color is for the upper limit, blue color is for the lower limit. This is simple multiplication. We know that, yes, indices, that's very, very necessary. That is what I've shown over here. 4 raised to power of 5 over 2 can be done in two ways. Ln of 1 is 0. That is used over here. And you simplify things. Either you leave the answer as it is or you simplify a bit further. They simply wrote, write the exact value. Find the exact value of this, a definite integral. So this is also good. This is also good. Question number 5. This is about differentiation now. The equation of a curve is y is equals to x tan inverse half x. Find dy by dx. That's the background knowledge that I need. Tan inverse of qx, the derivative is 1 over 1 plus this whole thing square. Don't forget to multiply by derivative of bracket. Y is equals to tan inverse x into tan inverse half x. When we differentiate tan inverse half x, 1 is there. 1 plus this half x, the whole thing square into half. This is the simplification that I've done and I've written it over here. Don't make things messy, because if you make them messy, you won't be able to realize where exactly are you going. The examiner is not going to take out a magnifying glass and then read the things for you. So this is not physics static electricity experiment. This is a magnifying glass. The examiner won't take out a magnifying glass. Keep that in mind. So now this is u, this is v prime, this is v, this is u prime. This is what you get. No need to simplify it because they are not asking us to simplify. The tangent to the curve at the point where x is equals to 2 meets the y-axis at the point with coordinates 0, p, find p. Now, this is the equation, the original equation. So let me highlight this, hold for a second. So that's the original equation. That is the original equation. When I plug in x is equals to 2, I get y as pi by 2. Therefore, this is the coordinate that I get. Similarly, this is x is equals to 2. I plug in dy by dx. So I plug in dy by dx. This is the gradient that I give. We know that gradient of tangent is dy by dx. That is after taking out the LCM. And this is 1.2, pi by 2. The tangent is passing through this. The tangent is meeting the y-axis. Does it say y? Yes, y-axis. So when x is 0, that's the y coordinate. The gradient between these 2 points is the simple. And then you get this exact answer. Next one, question number 6. This is about trigonometry, addition formula, and equation. Given that cosine x minus 30 is 2 sine x plus 30, show that tangent x is such and such in the exact form. Sine of 30 is half, cos of 30 is root 3 over 2. I have written sine as capital S, cosine as capital C. The first part is on this page. Apply the formula cos A, cos B plus sine A, sine B. Why? Because a negative sign for the addition formula gives a positive. Similarly, a positive in sine gives a positive. Sine A, cosine B, cosine A, sine B. Once you have written it, then write cosine 30 as this. Then write sine 30 as this. Cosine 30 as this. Sine 30 as this. Simplify. Take all the sine terms on one side. Take all the cosine terms on the other side. Take sine common out. Take cosine common out. Simplify. LCM. Simplify. LCM. That is what you are going to do. And then divide both sides by c. When you divide both sides by c, sine over cos is tangent. So let me also write over here. That is, remember the rule that sine x over cosine x is tangent x. That is the thing that is needed. And then make tangent the subject of the equation. So that is what you get out of this. The next part, hence solve this equation. You have already shown that this whole thing equals to this. So solving this thing is basically solving this thing between 0 to 360. Tangent x is this thing. I have converted into decimal. This is negative. I am working in 4 significant figures. Second and fourth quadrant, that's where tangent is negative. X lies between 0 and 360. No modification of range. Tangent alpha is this thing. Alpha is 6.21. Let me write this thing. What is alpha? Tell it to the examiner. Let alpha be the basic angle. That is the acute angle with the x-axis. So we found alpha is 6.21. In the second quadrant, it's 180 minus basic angle. In the fourth quadrant, this is 360 minus basic angle. This is in 2 dp. The final answer should be in 1 dp. All good. So now question number 7. It says by sketching pair of suitable graphs, show that. And now what do we have to show? Show that the equation sec x is 2 minus half x has exactly one root in this interval. Now what you are supposed to do is that you have to draw 2 graphs. And when you are drawing 2 graphs, one is about the trig function, which is sec x. So I have used a red line for sec x. And let me label a bit more. This is pi by 2. And this is 0. This is y-axis. This is x-axis. Now this thing is done. What else is there? Now over here, it says that we also have to draw this line. So when we have to draw this line, it has a positive y-intercept, negative gradient. So this is negative gradient, positive y-intercept. And it's intersecting at one point. So that shows that there is exactly one root. So let me write one statement over here. One point of intersection means one root of equation, whatever the equation is given. Also label the graph. Y is equals to 2 minus half x. And this red one is y is equals to sec x. So that makes things more clear. The second part is verify by calculation that the root lies between 0.8 and 1. So first thing that needs to be done, this is a must. Take all terms to the left hand side. So let me write over here, take all terms to left hand side. And the right hand side should be 0 because we are applying the concept of factor theorem. So now what we do is that we plug in the value f of 0.8. So f of 0.8, when we plug in, it is coming out to be positive. We don't need the value, we just need the sign. And f of 1.0 is coming out to be negative. Since there is a change of sign, therefore root lies between 0.8 and 1. The third part, that is the iteration thing. What it says is that use the iterative formula, that is the iterative formula, to determine the root correct to 2 decimal places. Give a result of each iteration to 4dp. So work in 4dp. What is the best starting value? Since the root alpha lies between 0.8 and 1.0, the best starting value is the mid value. Do not use any value outside of the range. So I'm starting with 0.9. I plugged in and over here. Make sure calculator is in the radian mode, and that's also written over here. When you work it out, 0.8695, that is 4dp. Now this value becomes the input. Again, the next step, you get 0.8777. Now 0.8777 becomes the input. You get 0.8755. Now stop and think. Are these two values the same after rounding off? The answer is yes, they are exactly the same. Therefore, just stop. The final answer is 0.88, correct to 2 decimal places. That's what iteration is all about. Question number 8. Now this is about what? This is about trigonometry, double angle you can see, and its integration. So prove the identity. Cosec 2 theta 1 over sine 2 theta. Cot 2 theta cosine 2 theta over sine 2 theta. Same denominator, add it up. That's the numerator. So now LCM is basically simple addition or subtraction because the denominator is the same. Sine 2 theta is written as 2 sine theta cos theta. Cos 2 theta, there are 3 ways of writing it. This is cos square minus sine square, 2 cos square minus 1, 1 minus 2 sine square. I have chosen the third one. Reason, this 1 and 1 cancels out, minus minus cancels out. Now you are in a position to divide. When you divide, what do you get? Tangent theta. The second part, hence show that the integral between this limit is half ln 2. What have you just proven? You have proven that this is tan theta. So now it's all about integrating tan theta. Tan is written as sine over cos. And which rule are we applying? If the numerator, let me pull this thing a bit up. If the numerator is the derivative of denominator. If the numerator is derivative of denominator, the integral of this fraction is ln of denominator. But what is the missing piece of the puzzle? The derivative of cosine is negative sine. I wrote a negative sign. In order to balance it, I wrote a negative 1 on the outside. And now this thing fulfills this criteria, negative ln cosine theta. Now the next thing is that I have switched these two places and removed the negative sign. That's a very, very famous rule that the examiner makes you apply. It's not necessary to apply, but it makes life a bit easier, a bit convenient. So now I plug in the upper limit. Let me choose a red marker over here. So red marker is for the upper limit. And then I choose this thing, the lower limit, which is pi by 3. Now we know that the cosine of pi by 3 is half. And we know that cosine of pi by 4 is root 2 over 2. And then I apply this rule of log. Which rule is that? Log x minus log y, that is log x over y. So this is like x, this is like y, minus becomes division, simplifies ln root 2. Root 2 means 2 raised to power of half according to rule of log. Let me write it over here. That is log x power m base a, that is m log x base a. So that rule is applied and this is the answer in the exact form. And they have already given us the answer. Now let's move on to question number 9. Now it says, express 4 cosine x minus sine x in this form. This is compound angle harmonic form. State the exact value of r and give alpha correct to 2dp. Hence solve this equation. 4 cosine x minus sine x is r cosine x plus alpha. If cosine is converting to cosine, the first coefficient is referred to as a, the second coefficient is referred to as b. So now what is the rule? R is square root a square plus b square, and alpha, this is tan inverse of b over a. We know that alpha is acute, r is positive. So that is the value of r, that is the value of alpha, correct to 2dp. Now the next part, hence solve the equation 4 cosine 2x minus sine 2x equals to 3. So what has changed? Instead of x, we are having 2x. Instead of x, we are having 2x. So the only thing that changes is that inside the bracket, instead of x, we write 2x and nothing more. We already have found the value of alpha. We already have, this is the value of alpha, by the way. This is the value of r. Equate it to 3. Now this equation over here, this is back to the basics, back to P1. First of all, state the quadrants. Modify the range. The range needs to be modified. X lies between 0 and 180. 2x lies between 0 and 360. 2x plus 14 lies between such and such. And let alpha be the basic angle. This is another alpha. That alpha was for part of the formula. This is another alpha. If you're not comfortable, use any other symbol. Cos alpha is this thing. Alpha comes out to be 43.31. Work in 2 dp. So now we are working towards the final answer, that is 2x plus 14 degrees. I'm just not reading out the decimals. 2x plus 14 something is this thing in the first quadrant, 360 minus basic angle in the second quadrant. The next step was just about subtraction. The third step was about the subtraction. Sorry, this thing was about subtraction of this. This thing was about subtraction, my bad. Subtraction of this. So 43 minus 14. 316 minus 14, then make x the subject. This is in 2 dp. Final answer, what is the requirement by the examination board? That is 1 dp unless otherwise stated. Question number 10. The diagram shows the equation y is equals to x over 1 plus 3x power 4 for x is greater than or equal to 0. That is for this side and its maximum point m. Find the x coordinate of m. Give your answer correct to 3 dp. So the first page is about this. Y is equals to this over this. This is u. This is u prime. This is v. This is v prime. And this time we are using the formula of which one? That is the quotient rule. Before we use the product rule. If y is equals to u over v, therefore dy by dx, that is v u prime minus u v prime over v square. So this is like v. This is u prime, this is u, this is v prime, this is v square. Just have a good look at it. And this is the expression for dy by dx right over here. Since it's a stationary point, dy by dx equals to 0. It's a stationary point, whether it's a max or a min. They are not asking about the nature, but for stationary point, dy by dx is 0. 1 minus 9x power 4 is 0. Therefore, x is this thing, correct to 3 decimal places. It's plus and minus because even roots, it will be plus or minus. But why are we only accepting the plus? Because from the sketch, we can see that the x coordinate is positive. That's right over here. All good, all clear? And the second part. Using the substitution, find by integration the exact area of the shaded region bounded by the curve, the x-axis, and the line x is equals to 1. This is the curve, this is the x-axis, and the limits are 0 and 1. First of all, u is root 3x squared. I can make x squared the subject, that's u over root 3. Ignore this for right now. U is root 3x squared, I differentiate, and ignore this for right now. I change the limits at the very beginning. This is the equation that relates the two. When x is 0, u is 0, x is 1, u is root 3. Now over here, I see this x and dx. So therefore, when I have differentiated it, this x dx becomes the subject. What am I left with? 1 over 2 root 3 du. 1 over 2 root 3 du. I have shaded it in red. Next thing, 1 plus 3x power 4. X square is u over root 3. Therefore, x power 4 is squaring this. It's squaring this. This is u square over 3. So this is replaced with u square over 3 in purple color. 1 and 3 and this one at the top remains as it is. Now, this 3 cancels out. This is 1 over 1 plus u square du. This is the changed limits. As soon as the variable is changed, the limits are changed. Now, what is the integration technique? 1 over x square plus a square. That's 1 over a tan inverse x over a. So x square, the coefficient has to be 1. And a square, this a comes down. And over here, there it is, 1 plus u square. The coefficient of u square, the variable is this thing. This 1 is basically 1 square. So this is 1 over a tan inverse u over a. And the limits are 0 and root 3. You plug in root 3, you plug in 0, tan inverse of root 3 is pi by 3, tan inverse of 0 is 0, multiply it out. I have rationalized it, and after rationalization, this is the answer in the exact form. Question number 11. Now it's implicit. Show that the derivative of this is this. Find the coordinates of the point where the tangent is parallel to y-axis. So differentiate each term with respect to x on both sides. X cube becomes 3x square. Y cube becomes 3y square. And there is this thing, my bad. That is 3y square dy by dx. So the blue goes with the blue. The red goes with the red. What about this? This is 3x into y square. This is u, this is v prime, this is v, this is u prime. Whenever you differentiate y with respect to x, you have to write dy by dx. And then you make dy by dx the subject, and you do a bit of simplification. This 3 cancels out. This minus changes the sign of one of these, and this is exactly what you were out to achieve successfully. The second part, coordinates where the tangent is parallel to y-axis. Dy by dx is gradient of tangent. Parallel to y-axis, gradient is undefined. Numerator over denominator is undefined. What makes a fraction undefined? Denominator is 0. So let me write it over here for you people for later on. Whenever it says tangent parallel to x-axis, let me write it like this. Tangent parallel to x-axis, and this is tangent parallel to y-axis. And this tangent is dy by dx, gradient of tangent is this thing. So over here numerator is 0, over here denominator is 0. That is the shortcut that you remember. So we have denominator equals to 0. That's the denominator equating to 0. Y is 0, y is 2x. Now when I plug in y is equals to 0 over here, no, not this thing, I'm just using this one. So when I plug in y is equals to 0, I get x is equals to 5 raised to power of 1/3. Yes, such numbers do appear. It's all about the exact form. When I plug in y is equals to 2x, I have to plug in the equation of the curve to solve it simultaneously. So I plugged it in and I get x cube as 1 and x is 1, and that is the other point. So let's double check. Cube root of 5 comma 0 and 1 comma 2, these are the 2 points. Now the last question of this particular paper, it says the variable x and y satisfy this differential equation x plus 1, 3x plus 1, dy by dx is equals to y. It is given that y is 1 when x is 1. Solve the equation, find the exact value, give your answer in a simplified form. All this for 9 marks. First of all, the very first thing, that is variable separable, separating the variable. So variable separable, I have written it, and then y goes with y and x goes with x. Now over here, this thing cannot be integrated right away unless and until I break it down into its partial fraction. It's a proper fraction, and it's which case? That's case number 1, denominator with linear factors. So a constant over the first factor, another constant over the other factor. We take LCM, we solve this thing using the concept of identity. Let x is equals to -1, we'll find the value of a. Let x is equals to any other value, we find the value of b. And I've skipped that step. I've just shown this working right over here. And this is what I get. So now this is -1/2, this is +3/2. So I've written the +3 first, the -1 later. I have taken this half, the 2 of the denominator common out. Simplify as much as possible. So that is the golden rule that you need to follow. So let me just write one thing. Simplify as much as possible. Let me write it. Simplification is the name of the game. The game about getting your star. Okay. So once you handle this, you're all set and ready to go. So now over here, what do we have? This integration technique would be ln, the same here, the same here. The coefficient of y is 1, 1/1 ln y. The coefficient of x is 3. This 3 was there. This coefficient is 3, 1/3 ln 3x plus 1. This coefficient is 1, 1/1 ln x plus 1. Now, instead of simplification, what I did is that I plugged in the value of x and y. I want to evaluate c, and c comes out to be half ln 2. So let me write it down. C comes out to be, no, not this thing. That is half ln 2. Now I have written actually negative half. So this is C right over here. And this is the red one that was there in the beginning, the ln y. And these two were the blue ones. The half is there and this thing is there, this thing is there. And what's next? What I have done is that I have taken this 2 common out, this 2 over here, this 2 over here, and I have taken to the other side, that's right over here. And now I am plugging in this particular equation. Now plug in x is equals to 3. Now when I plug in x is equals to 3, 3 into 3 is 9, 9 plus 1 is 10. 3 plus 1 is 4. All good. ln 2 is there, 2 ln y is there. Again, which rule of log is applicable? Log x base a minus log y base a, that is log x over y base a. So this minus turns into division. This is ln 10 over 8. This is ln y squared. This 2 is raised up. So there is ln on both sides. Therefore, y square is 5 over 4. Y is 5 over root 2. Y is 5 over root 2. That's the answer. And that finishes this particular P3 midterm exam. So I hope you found it useful. Let me know what other topic you would like me to focus on in the comment section. Till the next time, take care.